Now our Git repository contains 7 objects, 2 commits, 2 trees and 3 blobs. And using this diagram, let's discuss relations between all those objects. Before this second commit, Git repository looked like this, and we have discussed the structure. There was one single commit, root commit, that pointed to one tree object. Commit was a wrapper around this tree object, and the tree object had 2 links to 2 files, file1.txt and file2.txt, and there were 2 blobs. And after second commit, one new commit object was added, one new tree object was created, and one new blob. But all previous objects in our case remained unchanged. There are still those 2 blobs, there is this tree and there is this commit. If I'll go to Finder, you'll see here 6 folders in my case, because there are 2 files here in this folder. In your case, you'll probably see 7 different folders. And that means that the old objects were not deleted. Okay, let's have a look at this connection between 2 commits. Here is first commit, root commit, and here is second commit. And please note that timeline is here, and that means that this commit was created after this first commit, and that is pretty important for understanding. This commit is newer, it is more recent than this commit. That's why in this second commit there is a link to parent commit. And we have seen that in output in command line. There is separate line parent that contains SHA-1 of the parent commit. And root commit doesn't have this line, because this root is very first commit in our project. Okay, that is second commit, and description of this commit in our case is just second commit. Please note that here in a corner I have put SHA-1 of my commit. In your case, SHA-1 will be completely different due to different author and different timestamp. Okay, next this commit points to tree object. And the contents of the tree object should be, in your case, the same as in my case. That's why SHA-1 of this tree object should match with mine. Okay, that is a second commit. But question to you, how do you think why second tree, new tree was created? Why Git didn't just reuse this tree object? Answer is pretty simple. Contents of this tree object are different from contents of this object. There are 3 links in this new tree, and all 3 contained only 2 links to 2 files. Contents are different, that's why SHA-1 of the objects are also different. That's why Git has created brand new object with new hash in new folder, 31 in my case. Next, this new tree object contains 3 links to 3 different blobs. There was no need to create new blobs for file1.txt and file2.txt. That's why those blobs were simply reused, and links to existing blobs were added to this tree object. Here you see those links. But blob for file3.txt was absent. That's why Git has created brand new blob with such contents. And if you have entered same text in this file3.txt as me, this is third file in our Git repository, you should get exactly same SHA-1 as I get for this blob. And if this SHA-1 is the same, SHA-1 for tree object should be also the same. Because in your case contents of the tree object should be exactly the same as in my case. Same 3 links to different files. Okay, that is that simple. There is new commit object that is wrapper around new tree object, and this new tree object contains links to 3 blobs. To 2 existing blobs, first file and second file, and new blob for third file, file3.txt. And again, please note that file names for the blobs are located inside of the tree objects that are not located inside of the blobs. Blobs contain only contents of specific file plus size of the object and type of the object. And please pay attention on this relation between 2 commits. Here is timeline, here is more recent commit, and more recent commits have pointers to parent commits. And in such case, in our case, there is single parent for this commit, and it is root commit. Okay, I hope that now it is fully clear to you what happened in Git repository after second commit. 3 new objects were created: new commit, new tree, and new blob. And now we actually have 2 versions of our project, 2 trees. One tree contains 2 blobs and the second tree contains 3 blobs. And currently in working directory, here we see actually 3 files: file1.txt, file2.txt, and file3.txt. And now it's time to explain you how we can change, let's say, version of our project by moving to different commits. Now we are located at this commit, but we can safely move to previous commit and check out actually this tree. And let's start our discussion about traveling between different versions of the project by looking at this diagram. Let's discuss it in the next lecture. I'll see you there. Bye.